Alright, I want to go over the worksheet. You guys are pretty good at setup by now, I think, so I'll just go over the data analysis part. So, let's see. First of all, you definitely need to print this worksheet. It needs to look like this. If you're just filling out stuff in your workbook, you're missing out on some things, and you're not going to get credit. Your workbook doesn't have the graph, it doesn't have all the space in the tables, and it's missing a lot of things. There's two graphs, so it's missing both of those. So you definitely need to print this worksheet. It's on Moodle in the investigations folder. So anyway, in section 1, you need the car and the track and the marbles and the timer and the photo gates. So you're going to set up your track and you're going to use your car and vary the different masses. So you're going to start with no marbles in it, and then 1 marble, 2 marbles, 3 marbles. That's why there's 4 lines here. So you're going to record the photo gate times, calculate the speed. So remember to calculate speed. We've got distance over time. And remember that distance in this case is 0.01 meters because it's that little flag on the car, and the flag is 1 centimeter, and if you convert that to meters, it's 0.01. So distance moved, you can measure that along your track. That's just how far did the car go. Kinetic energy, this one we haven't done before. So this one, the formula is E sub K. That means kinetic energy. It's like energy subkinetic. To calculate, you do 1/2 mass times speed squared, or velocity squared. In this case, we're using speed. So that doesn't mean times 2. That 2 is up top. It means the same as if you did 1/2 mass velocity velocity. Okay, so times 1/2 times mass times velocity times velocity. Okay? So that is to find kinetic energy. Definitely write this formula down. You're going to need it in a couple of spots on here. Then we've got the force of friction. This is again another formula we don't know yet. So let me go over this one. So again, EK, kinetic energy, it equals force times distance. So kinetic energy equals the force of friction, that's F, times the distance. And the distance moved is a column right there, so you have that. And once you've calculated kinetic energy, you've got EK, and all you have to do is calculate F. Okay, so that is all of section 2. Alright, so now going over to section 3. This time you're going to vary the different speeds that you launch it at. So you're not actually going to know what speed you're launching it at. You'll calculate that, but just change how far you pull the rubber band back, stuff like that, and change the different masses. And that's why there's so many lines here. So I definitely want you to fill out every line here. Just change it up. Change the mass, change the speeds, all sorts of stuff. And then remember speed, distance over time. And when you're calculating the speed at A, you're going to use photogate A time. When you're calculating the speed at B, you're going to use photogate B time. But acceleration, remember acceleration, that's VF minus VI over T. And in this case, VF, final velocity, is the speed at B, VI is the speed at A, and then your time is time A to B, because you want the time overall. So that's why we have to have all these columns here. So now, part 4, calculate the speeds and acceleration. That's what you were just doing. Part B, if there was no friction, what would the acceleration be? You guys can handle that. Okay, so for part C, it's going to be a lot like that very first table that we did. So you're going to calculate the kinetic energy first, and then calculate the friction. So calculate the kinetic energy. Remember EK is 1/2 mass times velocity squared, and then you can calculate your friction. And the friction one is EK equals force times distance. Okay, they really should have had another column here for kinetic energy so that you can fit it all in there. Okay, now we're going to do the graph. So I'm going to scale the graph for you, and you guys can actually plot your data. But make sure you label all the parts of the graph. So the title could be friction versus mass. So on the y-axis, we're going to have friction, and that's in newtons. Then on the x-axis, let me scroll down, that's going to be the mass, and that is kilograms. Okay, so then for scaling here, just to make sure I fit everything in. So along the mass, I'm going to skip every 2 lines and go 0.01, 0.02, 0.03, and so on. Okay, so I don't think your car should get heavier than that, so that should be fine. Then the force of friction, let's see. Let's go. Okay. This time I'm not going to skip lines, so I'm going to go 0.02, 0.04, okay, that should be fine for your force of friction. Alright, so then go ahead and plot your data on there. If you need help graphing, you can holler at me in Blue Jeans and I can share my screen and do that with you. I'll save this right now so that I can just open up the graph and we can go ahead and do it. So let's see, you're going to answer a couple questions because on this graph you're going to graph both the sliding friction and the rolling friction. So that's going to be your 2 different tables. So the very first one, let's see. Alright, so you've got the very first table was the sliding friction, and then we've got the rolling friction because you're using 2 different cars. So the very first car you did, or it was the sled technically, it didn't have wheels, so it was sliding friction, and so that's going to do one thing on your graph. And then in this table 2 that we just filled out, it's going to be your rolling friction because it was with a car. So then going down to E here, oh, switch page. Okay, so comparing the 2 types of friction, and then how does friction vary with mass, comparing the 2, and then we're going to do another graph. So on this graph, we're going to look at force of friction and different speeds, but we're not looking at mass this time. Okay, so this time I'm going to put speed versus friction as my title. Friction is still going to go up the y-axis. Make sure you put that it's in newtons, and then I've got speed down here. That's always meters per second. So speed, let's see, I want to get all the way up to 1.2. Okay, I'm going to count every other one again. So we'll go 0.1, 0.2. Sorry, lost count. This one was 0.9 and then I have 1.0. Okay, and then going up the y-axis. Alright, so the y-axis is a lot more detailed because you're just looking at the rolling friction, and those friction forces are all very, very similar. I have example data here. So alright, so I'm going to save that one and we'll see how our data looks tomorrow. And you can Skype me and we can work on scaling it so that it fits your data. I don't want to scale it based on my example data here just because your data may be a little bit different and it's such a small range that it might not fit your data. So I want to make sure that we get it right for your graph. So tomorrow, if you need help scaling that, you can Skype me and we'll figure that out. Alright, so that is the end of that worksheet. So we're going to be working on this for Thursday and Friday, and possibly Monday, depending on how far we get. So I will be on Skype and Blue Jeans if you guys need help.